Thank you. It's a pleasure to be speaking to you today, and thank you so much to the organizers, especially Nitesh, who's done so much work to put this wonderful workshop together. So it's an honor for me to be talking to you this morning. So I'm going to talk to you about, as Nitesh mentioned, green chemistry, really thinking about it from education, implementation, and then looking a little bit towards the future. I should mention, actually, I'll go back one slide, just mentioned before I begin, that as Nitesh mentioned, Beyond Benign is a nonprofit. We're based in Massachusetts, just north of Boston in the US, and we are dedicated to green chemistry education, outreach, and training. We're co-located with the Warner Babcock Institute. You can see the logo up there on the right. And this is John Warner's organization. If you weren't lucky enough to hear him speak yesterday or the day before, this organization is dedicated solely to green chemistry technologies and inventing the next generation of green chemistry technologies. So we're very lucky to be affiliated with them and co-located with them as well. So, like I said, I'll talk to you today about education, implementation, and the future. So first, education, and of course this is very near and dear to my heart. And to think about this, I'll start with a traditional education of a research scientist or a chemist, or a material scientist, so to say. Think about our education. Typically, scientists might graduate from a pretty well-known school or research organization where they've been trained in various techniques, and they'll then get a research job in industry. And they'll have many times, sometimes, not all research scientists will come up with they'll have a great discovery. And this great discovery, when this is across industrial sectors, will then go on to scale up for further testing. It will then be handed over to the process engineer, the process chemist, for further scale up, further testing. Then sent to development and manufacturing to even then further scale up the process. And then a lot of times what happens at this stage is a problem is identified. They say, what solvent were you using in this process? We can't possibly scale this up. We can't possibly use this in a manufacturing setting. How you were using that reagent? How were you using that reagent? And can you use it at that scale? They're very different dynamics at the large industrial scale. So a lot of times we have to then either rework, redesign, or scrap the idea altogether. So if you think about this, and this is truly an education of a research scientist. We hear time and time again from from industries who say that they really have to retrain their scientists to think differently when they come out into industry. So thinking about this process, this whole process, where is the point where they can make the biggest impact in terms of what's going to happen at that manufacturing and industrial scale? It's that very first moment where a chemist or material science starts to begin to even think about the process that they're designing or the molecule that they're designing. It's that very first moment that they're making all of these determinations further on down the line. Each thing that they're thinking about at that minute is the most critical, so to say. And they're making all kinds of decisions for human health and the environmental impacts. So they're making decisions on where these raw materials will come from, where they will go, what types of reagents, what types of hazards the workers in the manufacturing setting will be facing. All of these, you're making that decision right at that very beginning stage. And that's why green chemistry is so important. So think about it this way. When is the appropriate time to start introducing green chemistry into the education of a material scientist or a chemist? Is it at the very beginning in grade school level? Is it college research level when you first start to begin to work in the laboratory setting? Or is it in industry when you already have well-established processes happening? And of course, I'm going to say way at the very beginning is also the most critical. So this is where green chemistry comes in. And really, we need this. We need students and scientists well-educated in green chemistry principles and practices in order to circumvent a lot of these things and really help design these processes right from the beginning. So to think about this a little bit more, I'm going to show you some statistics from the U.S. That's where I come from. But in the U.S., we are at a little bit of a crisis in terms of chemistry education and physical sciences education. It might be a little bit different here in India. But in the U.S., what this graph shows is by the time our students are leaving high school, grade 12, so about age 18 before they go on to college, about 50% of them have a below basic understanding of science. And you can see even in that small percentage at the top, which is actually advanced understanding of science, that even shrinks from understanding from grade 4, which is about age 9 or 10, up to grade 12. And so this then leads to, this along with many other reasons, leads to a decline that we're facing in the U.S. of students pursuing studies in the physical sciences. So this graph actually shows, I lost my X and Y axis, unfortunately, but this graph shows a decline. The black squares is the percentage of undergraduate students actually receiving degrees in physical sciences. And it's down on the left from 3% to about 1% in 2004, the last time that we had this study reported. And the circles are the total number of degrees given. And this is in physical sciences, which obviously chemistry is one component of. So we have a decline at the very time where we need safer alternatives. We need students entering into these fields to help us design these safer alternatives. So this is where we come in. Beyond Benign, I'll just show you our mission. This is kind of a big mission. We want to do it all, but we promote science driven by the principles of green chemistry in order to create an environmentally, socially, and economically prosperous world. And we do this through 3 different areas. We have here on the left K through 12, which is primary and secondary education. We call it K through 12, kindergarten through 12th grade in the U.S. And we do this through curriculum development and teacher training. I'll explain a little bit more about that. Community, so we find that scientists don't do too good of a job traditionally speaking to the public about what we do. So we take that to heart and actually spend a lot of time with the community. And the third is workforce development, which gets up to the undergraduate level and how we train our scientists. And these 3 areas, just really briefly, primary and secondary education, our curriculum development and teacher training. We're actually holding a teacher training workshop on Tuesday, if you know any teachers in your area. We'll be holding one on Tuesday here. And these are some of our philosophies. We work directly with teachers to design relevant curriculum materials, and they're based in these core sustainability values, which I'll mention again when I'm talking about green chemistry, which include the environment, economics, and social equity. Like I said, I'll revisit that again. They're pretty adaptive. We try to keep them relevant to the latest cutting-edge green chemistry technologies. And they're all free on our website, so we keep open access. Community, like I said, we participate regionally and locally and internationally as well to really help translate a lot of the green chemistry information that we have coming out there. Workforce development is really dedicated to how do you design and develop and maintain companies and attract them to a region and actually use local resources so that you can create a sustainable workforce and maintain some sustained economic growth within a region. So this involves training all levels of scientists, from technicians to the PhD scientists. So it's all levels of scientists are needed for this sort of workforce development. So I will revisit education throughout a little bit, but I'm going to get on to the next I, implementation. So how do we take this education and then turn it into, bring it to industry and implement it within an industrial setting? And we talk a lot about green chemistry? What are the barriers and how do we get overcome